Today we are going to learn about carbon compounds. What this chapter really covers is the chemistry of compounds all around us. Objects that we use every day such as foods, medicine, paper, wood, they all share an element in common, which is carbon. It would not be a lie if we say that the world around us is made up of carbon. In fact, chemists have synthesized or have discovered up to 10 million compounds that are just made with 4 elements: carbon, hydrogen, nitrogen and oxygen. All of these have a central element, which is carbon. The study of these carbon compounds is called as organic chemistry. Organic chemistry came out to be a science first in order to investigate the chemistry of life. People believe that anything organic has to have the compounds that are taken from nature. However, the very first organic compound, urea, was made in laboratory using inorganic starting materials, and then suddenly scientists started looking at organic chemistry in a whole new light, and they started believing that organic compounds can be synthesized in lab. Today we use a whole range of organic compounds or a whole range of carbon compounds which are pretty much there in everything around us: dyes, paints, petroleum products, cosmetics, food, etc. In the previous chapters, what we have seen are the ionic bonds or bonding in sodium chloride, for example, which is a great example of ionic bond where the two ions, cation and anion, are held together with the help of electrostatic force of attraction between sodium and chlorine. This is the strongest bond available. It is very difficult to melt ionic compounds. They have high melting and boiling points. They also conduct electricity in molten state, which basically means there are ions present in ionic compounds. If we look at the same thing in carbon compounds, they have lower melting and boiling points. This means their intermolecular force of attraction between two molecules is very low. Most of the carbon compounds, methane and ethane, are gases at room temperature. These carbon compounds also do not conduct electricity. All of these things indicate that these compounds lack ionic characters. What we call as a bond between two carbon atoms is a covalent bond. Next, we are going to look at the covalent bond. To give some other examples of covalent bond, the first molecule that you saw was the hydrogen molecule. Hydrogen has only one electron with it. In order to become the nearest noble gas, it has to be like helium, which is the complete electronic configuration of 2. For every hydrogen to gain 1 electron is going to be difficult because it's a very small size and it cannot have a charge of 2 electrons. What hydrogen does is it pairs with another hydrogen atom and then shares this pair of electrons in order to form hydrogen-hydrogen bond. The same thing goes on for nitrogen-nitrogen bond. What nitrogen does is it forms triple bond with nitrogen such that it shares 6 electrons between the two nitrogens. Nitrogen has its own 2 lone pairs, so nitrogen-nitrogen bond will have nitrogen with 8 electrons. Same with oxygen. And the molecule O2 has 2 pairs of its own electrons. It shares 4 electrons with other oxygen. So oxygen has its own 4 electrons and it shares the other 4 of them with the other oxygen. Totally it has 8 electrons. In order to form the nearest noble gas neon configuration, it needs to form oxygen-oxygen covalent bond, which is a double bond. So covalent bonds can be single bonds or double bonds or triple bonds. The main characteristic of covalent bond is that it is formed because of sharing of 2 electrons between 2 atoms. In order to understand the bonding in carbon compounds, let us first look at the electronic configuration of carbon. Carbon has 6 electrons and is 2-4. Remember that in its outermost shell, carbon has 4 electrons, so its valence electron is 4. In order to attain the nearest noble gas configuration, carbon has to either give up 4 electrons and be like helium. It has to become carbon plus 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 plus, which is not really a stable ion, so it has to bear the large charge of plus 4. It would be very difficult for this ion to sustain stably. The other noble gas nearer is neon. In order to become like neon, carbon would have to gain 4 electrons and become C minus 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 minus, or C minus 4. This does not seem like a great idea because the size to charge ratio is very small. That is, there is a lot of charge on a very small size atom. So carbon does not favor losing 4 electrons or gaining 4 electrons. In turn, what it does is it shares 4 electrons with another carbon or another element that can share electrons with it. For example, a carbon-carbon bond often forms where carbon donates one of its electrons and the other carbon donates other electrons, really sharing an electron pair in order to form this bond. Let us look at the electronic structure of methane. It is represented by Lewis electron dot structure. In this case, each electron in the valence shell is represented by a dot or a cross. Carbon, which is a central atom, is sharing 1-1 of its 4 valence electrons with 4 hydrogen, and 4 hydrogen are also sharing their electrons in order to form a carbon-hydrogen bond. 4 such carbon-hydrogen bonds are formed and we have the compound methane. These type of bonds, where bonds are formed by sharing an electron pair between 2 atoms, are called as covalent bonds.